Recall case 1 type triangles from our introduction to oblique triangles video. This case 1 is when one side and two angles are known in our triangle. In this video, we're going to use a technique called the law of sines to help us solve these types of triangles. The law of sines states in any triangle ABC with sides A, B, and C, side A divided by sine of angle A is equal to side B divided by sine of angle B is equal to side C divided by sine of angle C. Or we can flip this proportion and the law of sines remains true. Usually I use the first one. I don't know, I like my fractions to be bottom heavy. I just like the way it looks better. But either one will get the right answer. Let's determine the remaining sides and angles of each triangle ABC, rounding our answers to the nearest hundredth. Remember, this is also called solving the triangle, so the directions could be either. Here, they've given us two angles in our triangle. Since the sum of the interior angles of a triangle is 180 degrees, we know we can get the third angle right away. So our angle A is going to be 180 degrees minus our measures for angle B and C. So we get that angle A is equal to 36.54 degrees. One part down, two to go. We need to find sides A and B, and we'll use this new technique, law of sines, to do that. It doesn't matter which one we find first. I'm going to find side A first. Oh, side A, which is unknown, over sine of angle A, 37.54 degrees, is equal to, now you have to have a known pair. That's what you, to be able to solve this proportion, so we're going to have to use C. Now we know to use law of sines right now because this is the law of sines video, but when the problems get all scrambled up and you're trying to determine which technique to use, you know you can use law of sines when you have a known pair, a side and an angle opposite it. So that's the giveaway for law of sines. All right, we have our proportion set up. So now we can cross multiply. A sine of 74.08 degrees is equal to 45.38 times sine of 36.54 degrees. To solve for A, we'll divide. We'll plug this whole fraction here into our calculator. Make sure that you're in degree mode. And we're rounding to the nearest hundredth. We get our side A to be equal to 28.10, and our unit is meters. The last thing to be done to solve this triangle is to find side B. We're going to use this law of sines technique to find side B as well. Side B over sine of angle B, 69.38. Now, when setting up the second side of the proportion for your second answer, you want to make sure to go back to the known pair that was given. See, our side A value is a rounded value, and you don't ever want to start an equation with a rounded value, so go back to the original and go back to the known pair. And just like when solving for A, we're going to cross multiply. B times sine of 74.08 degrees is equal to 45.38 times sine of 69.38 degrees. And we'll divide to find B. Rounding to the nearest hundredth, we get B to be 44.17 meters. I feel good about these answers because if you'll notice, angle B is larger than angle A, so we would expect that side B would be larger than side A. So I always like to just look at those things, make me feel like extra sure about my answers. All right, let's try another one. We've been given two angles, A and B, and a side A. Since two angles have been given, we can get the third angle right away. We know that angle C is going to be 180 degrees minus angle A minus angle B minus angle B. We get angle C to be 66.2 degrees. On to the sides. Our first side, find whichever one you like. I don't know, I'm going to find side B first. Oh, side B over sine of angle B is equal to, remember to use the known pair both times that you were given. That's 42.9 over sine of 32. We'll cross multiply. B times sine of 32 is equal to 42.9 times sine of 81.8. And then we'll divide to solve for B. Plugging this into our calculator and rounding to the nearest hundredth, we get side B to be 80.13, and our unit is centimeters. We'll do the same exact thing to find our side C. Side C over sine of angle C, which is 66.2 degrees. And remember, you always want to go back to that original known pair when setting up your proportion. And we'll cross multiply. C times sine of 32 degrees is equal to 42.9 times sine of 66.2 degrees. And then we divide. Rounding to the nearest hundredth, we get side C, 74.07, and our unit is centimeters. And we've solved the triangle. Let's see how the law of sines can be used in an application problem. Two ranger stations are on an east-west line 110 miles apart. A forest fire is located on a bearing of north 42 degrees east from the western station, which they've labeled A, and a bearing of north 15 degrees east from the eastern station, which they've labeled B. To the nearest 10 miles, how far is the fire from the western station? Well, so here I've kindly given you the drawing. In the future, it's going to be really important that you can create this drawing, and I think that that's one of the most important parts about trig application problems is being able to draw yourself a good picture. So I'm just going to kind of walk you through the diagram based on their words to make sure that you would come up with the same diagram. So two ranger stations are on an east-west line, so that means perfectly horizontal east-west line, 110 miles apart. A forest fire is located on a bearing of north 42 degrees east from the western station. So we know west is on the left, so that station there. To do the bearing, we always, with this type of notation, we start at the north because they gave us north, and then we're going to rotate 42 degrees to the east to get the actual angle. And then it says the bearing is north 15 degrees east from the eastern station. So they started with a new north line and then rotated 15 degrees to the east, and you basically just have to extend those lines so that the two meet and create a triangle. Okay. So we're trying to find how far is the fire station, or how far is the fire from the western station. So what we're looking for is this right here. Okay, well, let's see what we know. Since this is a north line and this is an east line, they have to create a 90-degree angle. That means for us then that this angle right here has to be complementary with 42 degrees. This is going to have to be 48 degrees. Similarly, we know that this northwest line here has to create 90 degrees. And then we have that little extra 15 to the right. So this angle is going to be that 90 plus 15, 105 degrees. And since we know two of the angles in the triangle, we know that we can find the third angle because they have to add up to be 180 degrees. Or our third angle up here ends up being 27 degrees. Okay. In order to use law of sines, you have to have a known pair. Well, that's why we had to find that third angle up top, because the known side is here on the bottom, so the angle across from it to get our known pair is the 27. So we had to keep working until we were able to get that angle there. So there's our known pair. And then the side we're trying to find is B, so we're going to use the angle opposite that right here, the 105, to set up our proportion using law of sines. All right, so that means 110 over sine of 27 degrees is equal to our side B over sine of 105 degrees. And once we have it set up, it always finishes the same. Cross multiply and divide. B times sine of 27 degrees is equal to 110 times sine of 105 degrees. And we'll divide by sine of 27. Our direction said to round to the nearest 10 miles, so let's plug this in and then round to the nearest 10. We get our side B, rounds to 230, and our unit is miles. And since our angle B is so big at 105 degrees, I certainly expect this side B to be substantially larger than the 110, and it is.